my shit over.
Right.
Okay, this will be the last hour's worth. Some people have surged way ahead of even the content in this little bit of theory. So you guys can just happily
demo coders or
keep
something?
going forward. Yeah, and then there's some real life sort of advice from like live gigs and stuff, which probably no one knows unless they've done real performance things, which some people here have. Okay, hey guys, we're recording, so can you quiet for the next 20 minutes? Okay. And then you can be super loud, and then I won't care. You can be super loud all night. Okay, so everyone's kind of hit and run into and either had their machine fail or be totally successful with the OpenGL renderer. So this, you sort of know, with 3D stuff, OpenGL may be slower. For you, your card, just the way the processing talks to it, the actual implementation, it may be slower than processing these software libraries. So that may or may not help a lot. So if you want to make cubes, and some people have already found this, you can just call the box function, and everyone loves flying cubes. So if you throw a translate and a rotate in there with just some values that you made up, and you call box, then you've got cubes, and you've made all the demo coders happy. That's really trivial. For 3D model stuff, there are libraries to load and display 3D models, and I've got one of them in the libraries that I've included. I forget the name of it. These can sometimes be really slow, and some of that depends on the polygon count of your models, and some of it is like whether your hardware is behaving right, and some of it is just the libraries are really slow. So it may be faster if you want to do something interesting, like with 3D models that you're changing, to just call the OpenGL API directly. And processing wraps all of those in a really simple way. If you just look up the vertex example in the help, you can get a thing that'll show you how to do basic stuff, and that'll get you started, and you can just fly on with that. So, yeah, I'm not going to go into it in too much depth on video because it's way too much, but there's lots of resources, there's lots of processing examples, and talk to me afterwards. The basic idea of OpenGL is you have matrix transformations which change the orientation of your camera or your model, and then you just shovel triangles at it. And each time you specify a vertex, you specify the materials and texture coordinates for that vertex. That's OpenGL. And I'm not going to go through the code because I want to get through the live game considerations, and there are actually a great deal of information to go with that. So these are the topics for live game considerations. Everything's going to go wrong. As I've mentioned before, the projector's resolution is going to be completely different from your laptop's resolution, so you need to code around that. Brightness and contrast is going to be pretty terrible. It's going to be much worse than your laptop. Real input sucks. Know your audience, be safe, and does just trying to kill you. So now we'll go through all those details. So you need to make, if you are going to perform at a place that is not your home, you need to write down a pack list on a piece of paper. This needs to be every single thing that you need to be able to perform. So this means your power cord, which you forgot, your laptop, all of your cables to connect everything to everything else. But other stuff you might not think about is a power strip and an extension cord. The outlet for where you can get power may not be anywhere near where you need to be. Audio cables, it's really helpful to have a 1/8 inch, like a normal headphone cable that's male at both ends, because then you can plug your MP3 player or your